Welcome, you're watching Quacking the Code, and this is Git Animated. In this video, we'll be explaining how version control with Git works conceptually. If you'd like to also learn how to use either the command line or Git Kraken, my favorite Git graphical user interface, check the description. Git is a powerful version control and collaboration tool made for developers. Put simply, it's Google Docs for code. You can see past versions, sync your changes between machines, and back everything up in the cloud. First, a disambiguation. Git is an open source versioning tool. There are services that can host Git repositories in the cloud for you, almost like Dropbox or Google Drive. For example, some popular Git hosting services are GitHub, Bitbucket, and GitLab. This tutorial will be covering the Git system and some features that most hosting services provide, such as pull requests. Let's get started by learning how to use Git if you're working by yourself. Later, we'll apply this to if you're working on a team, but right now let's simplify things. Welcome to Git. Let's create a repository, a container for all your code. Go to GitHub, GitLab, or Bitbucket, create a repository, and make a copy on your machine by cloning it. Every repository comes with the default branch called main or master. Think of your branch as a quest log. At the tip of your branch is your code in its current state. But if you go backwards along the branch, you'll be able to see each change you made along the way. Each dot along this branch represents something called a commit, essentially a version of your project. Without Git, you might have to save a copy of your file each time you make a change, but Git does this for you in the form of commits. Let's create a new version of our project by adding a commit to the tree. Now let's add a message so when you look back, you know what changed in each version. We can simply use version 1, etc., but what would be more descriptive is a short line or two telling us what changed. Our new commit appears at the tip of our branch. If we ever want to see a previous version, all we have to do is check out a previous commit. This will put us in what we call a detached head state. But be careful, any changes you make in the detached head state get discarded when you exit by checking out the latest commit. Let's sync our project to the cloud. When we cloned our project, we told Git where it could find the server that will host our code. This is called a remote. By contrast, our copy on our local machine is called a clone. We can copy over our local changes to the server by pushing. Each time we add a new commit to the branch, we have to push to the server to save our work to the cloud. Let's say we have two machines which we use to develop. We can easily sync changes between the two machines using Git. First, let's clone our existing repository to our new machine. Now, let's say we make a change on one machine. We push the change to the cloud, then pull it on our second machine. Same goes the other way around. Here's the problem. What happens if we make two separate changes on both machines without syncing? We get a conflict. Usually, Git can automatically resolve this conflict, but sometimes we have to reconcile the changes manually. We'll talk more about merge conflicts in part 2. So, what have we learned? The big takeaway is whenever you make a change, you have to stage, commit, and push. Then, when you want to get the latest changes from the cloud, all you have to do is git pull. Let's say we have another developer join our team. To avoid the problem where we have to reconcile two different simultaneous changes, Git has a special feature called branches. As we've learned, each repository comes with the default main branch. But let's say we're experimenting with a new feature, and we don't want to put it on the main branch just in case we want to revert our changes. So let's create a branch to put our feature on. Let's add some changes to our new branch. Now we can incorporate the commits of our new branch back into our main branch by merging the feature branch into the main branch. The advantage of branches comes when we have multiple developers on our team. One person can create a branch to work on feature A, and one person can create a branch to work on feature B. Once feature A is ready to ship, we can merge it back into our main branch. Side note, when you're working alone, it's okay to merge branches yourself. But when you're on a team, when you're going from a smaller feature branch to a larger main branch, it's better to make a merge request, sometimes called a pull request, so others on your team can approve your changes first. Now, let's try merging feature B into main 2. Sometimes you'll be able to merge with no issues. But in other cases, such as if the two developers made changes to the same file, Git won't know how to automatically reconcile the changes. Imagine you're merging onto the freeway. You don't expect the cars traveling on the freeway to stop for you. Instead, you have to wait until there's an opening. Similarly, if you're working on a small feature branch, you have to incorporate changes from the main branch before you're allowed to merge. So let's first merge main into our feature branch. Git will tell us that there are conflicts that we have to resolve. So what have we learned? When you start to work on a new feature, make a branch. Put your commits onto this new branch instead of the main branch. To get ready to merge back into main, first merge main into your feature branch. Then create a merge request from your feature branch into main. And this was a brief overview of Git. If you're interested in learning how to use Git in the command line, click on the video on the left. Or if you'd like to learn how to use Git Kraken, click on the video on the right. Remember to subscribe for more code tutorials and see you later.